Thank you very much for this nice introduction. I will have a look where my presentation is. So I'm from the Austrian Met Service, and so I will tell you something about weather, but not the weather forecast for the next days, which will be sunny and warm. Okay, so first a short introduction of the Austrian Met Service. Here on this Google map you can see we are here in Vienna, the city center, and here we are now at Boku, and the headquarters of the Austrian Met Service is just 2 kilometers away here in the north of Boku. And our Met Service here in Austria is the oldest national weather service in the world. So we have a lot of experience already, gained in this more than 160 years. And you can see here on this list our main duties as a Met Service, which ranges from climatology, weather forecast and warnings in cases of emergency, and we are also responsible for geophysical topics in Austria, so earthquake warnings are also part of our job. For the agricultural topics, the most interesting thing will be the weather data that we are providing. And here is a short overview what we are providing on data, starting from climatology, which means everything in the past, data from the past which are very relevant both for climate forecasts and also for calibration of satellite data, for example. And we have some of the longest lasting temperature series all over the world here in Austria, so we're in a very lucky position here in Austria. When we're coming to the present, the so-called analysis, here we are trying to combine all data that we can get to get an idea of the current state of the atmosphere, because we have to know that so we can make good forecasts, only if we know what is going on right now. Then we have here this small part of the so-called Nowcasting. This is up a few hours, usually 2 hours, sometimes it's also the range up to 6 hours, and typical applications are thunderstorm cells. Where will they track is hailfall, for example. Severe weather warnings are a typical application of this Nowcasting range. Then we have the classical weather forecast, from the short range forecasting to medium range forecasting up to about 2 weeks. Here up to 3 days ZAMG is running their own weather forecasting models, and for the longer ranges, and for the longer forecasting ranges up to 7 months, there's a common organization for European countries in England, which is running global models providing this long-term weather data. Today we'll mainly focus on the analysis and nowcasting range, because this is the most relevant aspect maybe for agriculture, and also from the seasonal forecasting some research that we are doing which might also be of interest for farmers. In the analysis and nowcasting range we have our own forecasting tool. It's called INCA, that's integrated nowcasting through comprehensive analysis. And the idea behind the system is that we are trying to combine all data that we can get. On the one side, this is model data from different models with different forecast range and resolutions, and they are combined with in situ data from meteorological stations at the ground, but also radar, weather radar data and satellite data. And this is all combined in a clever way. And then we can generate products out of this forecasts, for example, for hydrological forecasts, warning for floods, and also warning for other severe weather events like hail or storm events. And we have tailor-made products for our customers. For example, here on Lake Neusiedl, there are wind forecasts for water sports. I told you that we are trying to combine all these data sources we can get, and I want to show you one example how this is working for precipitation. On the one hand, we have ground measurement stations which are providing precipitation measurements, and if we interpolate them to a regular grid, this is part of Austria, has Salzburg and Upper Austria, then we get this spatial pattern of precipitation, but this is in a range of about 20 to 30 kilometer spatial resolution, which is not enough for precision farming, as far as I understood. And that's why we are combining this with radar data. And here you can see for the same region, we have a lot more spatial pattern, more details, but the amounts that the radar is measuring, they are not as accurate as from the ground stations. And so with some climate data, we are able to calibrate the radar data, and then in the end we can combine these both fields, and this is the result of the analysis, and you can see that we now have this fine spatial pattern of 1 kilometer, which is provided by radar, but the amount of precipitation, it's mainly here from the ground measurement stations, and so this is the best precipitation analysis that we can get. And yeah, as for precipitation, we are also doing that for other parameters using either satellite or model data. And if we are made the analysis, we can then go to the nowcasting range, and here's an example. You can see the precipitation cells, and if I'm clicking here, then we have the forecasts where the cells will be moving, and this is a probability that in 2 hours from now, where the cells will be located. This is one of our applications, and these data, they can be accessed, for example, by farmers via the web portal of the Austrian hail insurance, and there, if you are a partner of this insurance, if you have a contract with them, then you can log in and access the data. Here you can see the map with the radar data, and they also have a mobile app, so you can access these data, and there you have precipitation, the nowcasting of precipitation. You have weather forecasts with 1 kilometer resolutions up to 7 days, a database with historical weather data, and there are also some GIS applications and search function, and as a feedback for the insurance, you can also provide damage reports to them to get in contact with them. Another tool that we have developed for the nowcasting of thunderstorms is this so-called A-TNT, and here we are combining radar data. Here you can see a movie of these moving cells and lightning data. So we have two different and independent data sources, and this algorithm is detecting regions with high impact weather where we have high reflectivity of the radar. And here you can see this these gray lines. This is the forecasted track of the thunderstorm cell, and if you are a customer of ZAMK, then you will get hail warnings looking like that via SMS, telling you that within the next 20-30 minutes there is a high probability that a thunderstorm will approach your position, and this is based on postal codes where you decide for which location you want to have this warning. So these are the main applications in the nowcasting range. Of course, we're also providing longer range weather forecasts, but usually they're on a much larger grid with a lower spatial resolution of 20 to 30 kilometers. And now I want to present some of our research. Most of it is done over Africa because we have some projects that were funded for this region, but in principle all this application can be applied to Austria without problems because they're all based on satellite data and global weather forecast models, so it's just changing the coordinates where to run these products. The first one is an approach to downscale soil moisture forecasts from a global seasonal model. Usually we have the problem that the forecast of the model, here we have Kenya and Somalia, that they have a spatial resolution of about 500 square kilometer, which is far too low for most application. And we were trying to downscale these to 1 kilometer by using satellite data. There are several satellites providing soil moisture information, for example, from METOP, ASCAD or Envisat ASAR, or in the future there will be Sentinel-1 providing such information. And by combining these model and satellite data, we could show that here we have the model forecasts for up to 7 months of soil moisture at a specific location. And there are some soil moisture measurements in Kenya. And here you have the observed soil moisture at this grid point. And this is the original model output. And here you can see the downscaled model output on the 1 kilometer grid. It's fitting much better to the observations, and we were quite happy with these results because it was a totally new approach to do this. Another project, also FFG funded, is running right now. It's called SATIDA, and here we are trying to provide drought indices here for Central Africa at the moment. This web interface is developed by TU Wien, and here is the idea that we are using satellite data to monitor the current status of the crop and calculating the current drought indices, and then combine this with model forecasts to mainly give here, we are in cooperation with Doctors Without Borders, to give such companies an idea how the crops will develop through the season and to start aiding programs if necessary. This program is going right on, and so we are still in the validation phase to see if this application is working well. And the last one is an outlook on the Sentinel data. At the moment, we are running another FFG project where we are trying to become the national mirror site of ESA so that we can provide this Sentinel data to Austrian users more easily than via this scientific data hub. There are mainly some legal issues still to discuss, and for us the next project will be here another FFG funded one where we will try to assimilate this soil moisture from Sentinel in our weather forecasting model. So this is all from my side, and I hope that I will learn something more from you, what your interests are to the meteorologist, which requests you have, and I'm looking forward to a fruitful discussion. So, thank you.
From among the few farmers who said were present here earlier on, Does any of you use the information service that was shown just now? You do. Sorry, I need to give you a microphone because otherwise you won't show in the... Just a second. Otherwise we don't record. If you don't have a microphone, we can't hear you.
I use the service from the hail insurance.
Did you use it to claim your insurance costs? To claim money from the insurance? Is that... No, how do you use it?
To see the weather forecast, mainly for the Niederschlag.
Okay. So it's interesting to see, do you have statistics on who uses the service? How many farmers use it? I'm talking about the operational nowcasting and short-range forecast. Do you have such statistics? Do you know who uses it?
We don't have the statistics because this web service, it is provided by the hail insurance. But as far as I know, everyone who has an insurance there can access the system. And as far as I know, it's widely used, especially the precipitation. The short-range forecasts are of high value for the farmers.
Mm-hmm. Because I was wondering on the provision model, if Metop provided the service, that I'm sitting here for the camera, if Metop provided the service directly to the farmers, or if you needed an intermediary. And it turned, because we're also interested in the model of distribution, as I said earlier on, in how do you get this data to the final user. So I understand that the insurance company is a big ally in intermediating this sort of information and bringing it to the end users, I guess.
Exactly. So it's a service of this hail insurance for their customers. Mm-hmm. From the technical point of view, we can also provide this data via our webpage, but it's a service of them. So we're cooperating here to give this insurance the possibility to give some additional value to the product.
And have you already talked with the insurance company about including some other data for farming, precision farms, such as soil moisture content or any other sort of data?
Well, the problem with precision farming from our point of view is that the spatial scale that we can provide is usually we're in a scale of tens of kilometers usually with our forecasts. So for precision farming, as far as I understood, this is far too low a resolution for an individual field of a farmer. So at the moment it is not planned to add some additional information because we are not convinced that the quality of the products would be really helpful for the farmers at the moment.
Okay, we hope to learn from the next presentations. If or not, this would be suitable. Are there any other questions in the room?
Just one comment. It's really not my field, this weather forecast, but in the remote sensing community we made several big mistakes. One was to try to get money out of the data. You know, and the experience was that especially the Europeans launched huge satellites, very good satellites, and almost nobody was using later on the data because you had to pay for. Whereas the Americans say, okay, once the people of the country paid for the satellite, all the data should be free. So that is a bit the feeling I have also with, let's say, weather-related data. You try to make some money out of it, and perhaps this is not what we should do. Perhaps you should try to find another way to get some money in through advertising or whatsoever. Because I'm sure, and this is our experience when we look at the Landsat archive, once they open and make available all the Landsat data a couple of years ago, you know, the use exploded of this data, you know, and companies were spin-off, and so that is, I know you're not in a position probably to change this policy, but to give you a feedback of my feeling.
Yeah, I agree with you from the scientific point of view. I would also feel happy if we could give away our weather forecast data for free, but nowadays, as the state is discussing to reduce budgets more and more, well, we have to somehow finance our personal costs, and yeah, to sell the weather data is one possibility.
This being said, if you will indeed set off a ground segment for Copernicus, you will you will basically give away Sentinel data for free. If you will create the mirror site in Austria.
That's part of the agreement, that the mirror site is providing this data for free to all customers in the country.
I think also another confusion is often occurs at the user level, is that the farmers think that, oh, if Sentinel data is free, the service will be free for me. Whereas it's not really like that, because the data needs to be transformed and provided as a service to the farmer. So even though the data is free, we shouldn't perhaps mix the message that all the services will be free. And I think it will be interesting later on in the roundtable to understand who should provide these services. Is there a competition between the private sector and the public sector? Who should intervene at which level of the value-added chain? I think that's also an interesting question to take for later on.